All right. Hello, everyone. Good morning, good afternoon, good evening, whatever time of day it is for you. This is Mrs. Rondo. We're going to be talking about the Unit 4 practice test that was in Otis. We're going to be working through the problems so we can prepare for our test tomorrow. So here goes. Number 1. Order the triangle sides in order from least to greatest. Definitely want to make sure that we are reading the order. So we want least to greatest, which is going to be small to big. So I'm going to start with the smallest angle. And so to do this problem, we need to remember something we learned at the very beginning of the unit, that the smallest angle, in this case the 45, is always across from the shortest side. So I'm going to connect smallest angle. I shoot across to the shortest side, which would be side AC. Then I'm going to change colors so we can get to the next one, which is the next smallest angle would be the 65 up here. And so then across from 65 is going to be the next smallest side. In this case, that is BC. And then finally, our final angle, the 70, happens to be the largest angle in this triangle. Across from that largest angle is going to be the largest side, which is side AB. And so I wrote them in, but you can see there's the different side choices that you'll see in Otis when you practice this. All right, on to the next one. This one, order the triangles, angles from least to greatest. Again, double check the order. We're going least to greatest or small to big again. So I'm going to start with the smallest number I see, which is 6. And then I want to go across from the 6 or opposite the 6. I actually go back over here to angle A. So same concept. This time we're just going from the sides to the angles. All right, so then I'm going to change colors and go to the next biggest number I see, which is the 13. And then I go back from the 13 over to angle B. And then finally, the last remaining side, which is the 14, and I shoot back over here to angle C. So again, the shortest side is across from the smallest angle. I was getting my words mixed up there a little bit. Let me just draw that a little bit nicer for us. There we go. All right, on to the next one. And this will not always happen where we see angle A, B, C in order. So don't just write them in order. Make sure that you are checking it with the triangle. All right, on to the next one. So this one is questions. This is actually questions 3, 4, and 5. I put them all together because they all happen to use the same right triangle. That may or may not happen on the actual test. Since they all use the same right triangle, I'm just going to label one of them. So I'm going to start with theta. There's my angle. And then I'm going to label my sides. So my hypotenuse is what I'm going to start with, always across from the 90. Then we have the opposite, which is across from the angle, other side of the triangle from the angle. So that would be 8 is the opposite. And then finally, next to the angle is the adjacent. All right, so once I have them labeled, then I'm going to go through and find, we have 3 different questions: cosine, tangent, and sine. We're going to start with cosine, and I'm going to jot down as a reminder, SOHCAHTOA. There we go. All right, so with SOHCAHTOA, that, remember, is going to help us decide which sides of the triangle we need or which trig function we need. For cosine, cosine starts with C, so we're going to be looking at the ka of SOHCAHTOA. C stands for cosine, and I know I'm going to use A and H, which are adjacent and hypotenuse, or I would say adjacent over hypotenuse. So I fill in the numbers. Adjacent is 15 and hypotenuse is 17. Then I'm going to move over to the next trig function that we're asked for, which is tangent. So looking at SOHCAHTOA, remember tangent starts with T, so we're looking at the TOA. And so T for tangent, and then O and A for opposite and adjacent. So this is going to be opposite over adjacent, and then I'm going to fill in those numbers. The opposite is 8, and the adjacent is 15. And then finally, the last one, sine theta. For this one, I'm going to actually go back and erase. I'm going to go up to SOHCAHTOA one more time, and this time I'm looking for sine, which is the SO of SOHCAHTOA. S for sine, and then I'm doing opposite and hypotenuse. So sine is going to equal opposite over hypotenuse. Again, all that coming from SOHCAHTOA. Then I fill in those numbers. Opposite is 8 and hypotenuse 17. Alrighty, that finishes that. Those are, again, questions 3, 4, and 5. On to the next. A right triangle is shown below. Which value is closest to B? So we want to try to figure out B. I'm going to start by marking my angle and then figure out which sides of the triangle I have. So from 40 degrees, B would be the opposite. So on the opposite side of the triangle. 17 is across from the 90, so it's going to be the hypotenuse. So I'm looking at opposite and hypotenuse. I'm going to grab SOHCAHTOA again. And specifically here, I'm looking for O and H for opposite hypotenuse. I see that in sine. I'm going to try that one more time just for the prettiness. There we go. It's a little better. All right. So I'm going to be using sine because I have opposite and hypotenuse. So I would say sine 40 degrees equals, and then my opposite is B. My hypotenuse is 17. All right, so I'm going to not pause the program, but pause the solving for just a quick second. A quick side note here, on the test, it's very important that you write out the equation that you're going to solve. So you will be asked to turn in your scratch paper. If you get the setup of any problem correct, you will earn 4 out of 7 points. Each question is roughly 7 points. So you're going to earn 4 points for just setting it up correctly. Then if you by chance get it wrong, you keep those 4 points. If you end up getting the question wrong, you get the 4 points. If you get it right, then of course you get all 7. So definitely important to be writing out our equations in our scratch paper. All right, back to the solving. To solve, I'm going to make this, the way that we talked about solving trig was making this into 2 fractions with an equal sign. So I'm going to make sine 40 a fraction by putting a 1 under it. And then I'm going to cross multiply, and I'm going to do it with blue this time. I'm going to cross multiply, do the love connection. So we get a nice pretty blue heart. It's kind of a pretty heart. All right, so I'm going to follow the path starting with the 1 times b and bring it down is b. Then I go to the 17 times sine 40. It's not 17 times 40. Remember that 40 represents an angle. We're not multiplying 17 times the angle. We're doing 17 times sine 40. So I write it like this. 17, whoopsie. I'll write it a little bit nicer than that. All right, so 17 times sine 40. Now, for this one, once I cross multiply, I happen to already have b by itself. So I don't have to do any more solving for b. I'm going to take this side of my equation and put it into a calculator. So I'm going to show that on Desmos. On the test, it will have Desmos calculators built in. So you can just use that calculator. So I'm going to show this with Desmos. 17 sine 40. All right, if you are doing it, don't mind that. We're going to hop over to Desmos. Here we go. If you are doing Desmos from the website, you need to make sure that it's in degrees. So we're going to check that with the little wrench here, graph settings, and we're going to go down and click degrees. As long as I do not X this out and exit the web page, then it will stay in degrees the whole time. So I only have to do it once. Then we're going to type in, it was, I believe, 17. And then I need my trig functions. I need this guy to go away for a minute. Sorry. All right, so down here, so this one is because I'm recording, so don't mind that. That's not important. Over here, I have the show keyboard. I'm going to click on that. I'm going to come over here to functions, and I'm going to click on sine, and then we type in 40, and it will automatically pop up with an answer. All right, so I have 10.927. Let's go back to where we were. All right, and back to blue. That was 10.927, I believe. But really what's important here is that we are looking to match up with our answer choices. That's going to match up with this one. I don't know what's happening. My little circles aren't completing properly. Circle that one more time. It still did it. It still did it. It still did it. Ha, better. All right, next one. The drawing below represents a 22-foot ladder with its base placed 10 feet from the bottom of a vertical wall. Which value is the best estimate for x? So here we're going to be solving for x, which is the angle. So I'm going to mark that. And before I jump in, I'm going to figure out which sides of the triangle I have. I'm going to start over here with the 22, which is our hypotenuse because it's across from the 90, the right angle there. And then the 10 is next to the angle, so this one would be adjacent. All right, and then in terms of setting this up, I'm going to borrow SOHCAHTOA again. And so I have SOHCAHTOA. I'm looking for hypotenuse and adjacent. So I see that right here, hypotenuse and adjacent, A and H, which means I'm going to do cosine. So I set up cosine. My angle is x degrees equals, not opposite, cosine is adjacent over hypotenuse. So I would say 10 over 22. All right, so this one, that is the initial setup. Then when I go to solve it, I need to get x by itself. So I have to undo or get rid of the cosine. So typically always we do that with inverse operations. So what is the opposite or the inverse of cosine? It's inverse cosine. So I'm going to show this as a quick separate step. So I'm going to write out my equation one more time. And then I'm going to jump in and inverse cosine both sides. So cosine inverse, both sides. All right, so then when I'm solving, the cosine inverse and cosine cancel. I have x. On this side, this is what I'm going to put into Desmos. So here we go, back to Desmos, doing cosine inverse of 10 over 22. So back over to Desmos. All right, so I'm going to do cosine inverse. So in my keyboard stuff, I'm going over to functions, cosine inverse, or inverse cosine, and then I'm going to do 10 divided by 22. And it gives me 62.964, blah, blah, blah. So 62.964. And so I have, oopsie, wrong color. 62.964. And continuing, when I look at my answer choices, that most closely goes with 63. So remember, you're looking which value is the best estimate. So that's the closest. All right, then that's it for that one. Let's go on to the next one. Right triangle is shown below. Which measurement is the closest to the value of x? All right, so I'm going to mark x. I'm looking for an angle. So I'm going to go through and figure out which sides of the triangle I have. I'm going to start with the hypotenuse if I'm given that. In this case, I am. Here's my hypotenuse, is the 100. And then the 57 would be the opposite because it's across the triangle from x. So I'm looking at opposite and hypotenuse. So let me grab SOHCAHTOA real quick. SOHCAHTOA. Opposite and hypotenuse are here, so I'm going to use sine. So S for sine. Sine of x degrees equals, then I fill in opposite over hypotenuse, 57 over 100. All right, and again, I'm trying to solve for x, so this time I'm getting rid of or trying to undo the sine. I'm going to do that with my inverse trig in just a second. I'm going to rewrite this guy so we can see that step. All right, so I'm going to grab blue again, and I'm going to inverse sine, or sine inverse both sides. So I do that to both sides. All right, then my sine inverse and my sine cancel. I have x. On this side, again, this is what's going to go into my Desmos. So I'm doing sine inverse 57 over 100. All right, so I'm going to do, that was sine inverse, so I go to my functions, sine inverse, and then it was 57 over 100. And I get 34.750, blah, blah, blah. 34.75. 34.750, blah, blah, blah. And again, I'm looking to match it up. So when I look at my options, the one that is the closest is the 35. All right, on to the next one. All right, we're using triangle QRT to answer the question, which measurement is the closest to the measure of angle T? So looking for angle T. Sorry, I don't know why I erased that. Didn't need to, but that's all right. Angle T. I'm going to mark angle T first, and then I'm going to label my sides. This time I don't have the hypotenuse. That's the one that's not given. So I'm going to continue labeling the sides. I see that 8 would be the opposite. 3 would be the adjacent. Then I'm going to borrow SOHCAHTOA. All right, and then I'm going to look for opposites and adjacent, or adjacent and opposite. I see it right there. So I'm going to use tangents. So tangents of, I could say tangent T for the angle. And then opposite over adjacent is going to be 8/3. And again, I'm looking for T, so I have to get rid of tangent. I'm going to do that with my inverse trig. That's the opposite of a trig function is inverse trig. All right, so I'm going to just write this equation out one more time, and then I'm going to show taking the inverse. So I'm going to inverse tangent both sides like so, and tangent inverse and tangent cancel. So I get T. On the right-hand side, this is what I'm putting into Desmos again. So tangent, or inverse tangent 8/3. Let's try that out in Desmos. Inverse tangent 8/3. Pop back over to Desmos. On to the next one. So now I'm doing my functions here, inverse tangents. And I'm doing 8 divided by 3. So I get 69.443 and so forth. 69.443. And then to match it up, that one would be the closest to this guy. So be careful, there is 68 there, but it's more close to the 69.4. All right, on to the next one. What is the length of AC in the figure below? So this one, I can mark it AC, I'm going to call it X. So I could set up a trig function using either the 30 degrees or the 60 degrees and solve to find X. I could do that. If you, and I'll show that in a minute, if you happen to recognize this is a 30, 60, 90 triangle, that would be our 3 bears. The side of the triangle they gave me is the hypotenuse or Papa Bear. And we know that Papa Bear is twice as big as Baby Bear. So if Papa Bear is 24 and he's twice as big, then Baby Bear would have to be half of that, which is the 12. So you can very quickly do this problem just by knowing the 3 bears. Now, if you didn't know that, for example, you could have done, I'm going to just pick my 60 degrees as my angle here. I could set up a trig function. If I do that, from 60 degrees, the X side here is the adjacent. The Papa Bear, we already said, is the hypotenuse. And so I could do, stealing from SOHCAHTOA, I grabbed adjacent and hypotenuse, so I could do cosine 60 degrees equals adjacent, which was the X, over hypotenuse, which was the 24. So I could solve that equation, which would end up giving me X equals 12, or again, using the 30, 60, 90. So I just wanted to show there is an equation you could write. There's more than one that you could do. You could do a different one with the 30 degrees, however you want to do it. But either way is fine. It's a lot faster if you do the 30, 60, 90, but if you don't remember it, if you forget it, it's okay. You can still solve it by doing that. So I'm just really quickly, there we go. All right, on to the next one. This one, a right triangle is shown below with the dimensions given in units. What is the value of X in units? So they wrote X for us. This is a 45 45, 90 triangle, which is our Zach and Cody twinsy triangle. So again, if you remember that, you can really quickly say, okay, X, which side of the triangle is X? It is the sweet life. And then the side they gave me is either Zach or Cody. And based on how we did it in class, I'm going to say this was probably actually Cody. So down here would have been Zach, and over here would be Cody. So Zach would be 6 and Cody is 6, but we want to know what X is. So remember, we take whatever the twinsies are, and then we tag on the square root of 2. So 6 square root of 2 would be the answer. If you decide to do this as a trig problem, you could, if we mark the angle, you could set up a trig equation where the 6 that's given would be your opposite. And then the X over here is the hypotenuse. So you could do opposite and hypotenuse. Just write that a little bit better. There we go. All right, so if you're doing that version, opposite and hypotenuse are actually the SO of SOHCAHTOA. So we would do sine. You could say this is sine of 45 degrees equals opposite, which is 6 over hypotenuse, which is X. Now, when you solve this out, you're going to end up getting a decimal, which I will really quickly calculate for you what that decimal is. It would be, we want 6, hold on one second, 6 and the square root of 2. So that would be the only thing you would have to check, like what those values are. You'd have to multiply them out on your calculator. So when I multiply that out, sorry, having a slight calculator delay. 6, I had to change a setting. I get 8 points. So 6 square root of 2 is what you would end up with, which is approximately 8.485. Well, it's 8.485 and so forth, not approximately. All right, so the point is, though, if you did do a trig equation, you would need to, your calculator probably would not tell you the 6.2 or 6 square root of 2. It would give you a number like 8.485 dot, dot, dot. Okay, so you would need to go through and calculate out these two and see which one matches the 8.485. And I'll tell you really quickly what the other one is, just for argument's sake. 6 times the square root of 3. This one gives me 10.392. Okay, so that would be your way to do it. If you did it with trig, you could still verify that your answer is correct. Again, Zach and Cody is going to be a lot faster. All right, our last one, guys, last one. A radio tower has a support cable attached to its top. The support cable is 140 feet long and is anchored in the ground 98 feet from the base of the radio tower. So they give us all the information. They ask us to find the height of the radio tower, the angle of elevation, and the angle between the cable and the tower, and round all of our answers to the nearest whole number. It's really important to read the directions. Whole numbers. All right, so starting off with this one, I have lots of things to find. You can pick any one to start with, X, Y, or Z. I'm going to pick the thing that, again, I know the most about. In this problem, I know 2 sides out of 3. I know the 98 degrees and the 98 feet and the 140 feet. So I'm going to choose to find the side, the missing side first, the thing I know the most number of sides. So I'm going to find that last missing side. So I'm going to find X. I'm going to do that using one of my strategies. I could try to set up trig, but it won't work very well because I don't know the angles in my triangle other than the 90. So instead, I'm going to use Pythagorean theorem, which is a squared plus b squared equals c squared. And I'm going to make sure to focus on the c, of course, is going to be my hypotenuse. We want to make sure to get that right. So I'm going to do that first in my problem. The hypotenuse is the 140 feet. So I put in 140. And I know that because, again, it's across from the 90. There's your 90. All right, then I'm going to plug in for the others. It doesn't matter which one is which. I'm just going to say x squared plus 98 squared. and then equals. So here's where I'm going to grab some calculations for my calculator because I don't know this, and I'm going to do it quickly and not show Desmos. So I'm just doing really quickly 98 squared. So I have x squared plus 9604 equals 19,600. All right, so then I'm going to go ahead and solve for the x squared by subtracting 9604 from both sides so I can get my x squared by itself. So when I subtract, I get, that cancels out. I have x squared equals, over here, I get 9,996. Now, that's not quite finished. I still have x squared equals that. I want x by itself, so I'm going to square root both sides. So I get x equals 99.979 ... All right, so it does say round to the nearest whole number. So rounding that to the nearest whole would be 100, and that would be feet. All right, that takes care of the side. Then I'm going to go through now and find the angles. And it, again, doesn't matter which one you do first. I'm just going to pick angle Y. So I'm going to mark that angle. Then I'm going to pick some sides to help me out with trig. And I'm going to typically pick, actually I didn't write this in, but we know that x is now 100 feet. So I could choose any of the sides, but I'm going to say that I typically want to choose sides that are already given to me because then they're not rounded numbers. So 98 feet would be my adjacent, and the 140 feet would be my hypotenuse. So I have adjacent and hypotenuse. I'm going to borrow SOHCAHTOA again. I'm looking for adjacent and hypotenuse. That tells me to use cosine. And again, it's in reference to the angle because we chose angle Y. From angle Y, the side, the hypotenuse is what it is, and then the side next to it is the adjacent, the 98. So I would say cosine of Y degrees equals adjacent over hypotenuse. And then to solve that, I need to get Y by itself. I've got to inverse cosine both sides to get rid of my cosine. So I have cosine Y equals 98 over 140. I'm going to inverse cosine both sides like so. And cosine inverse and cosine cancel, I get Y equals. On this side, that's what I get to put in my calculator. And here we will go and look at that. I'm doing inverse cosine 98 over 140. So jump over to Desmos. So on to the next one, inverse cosine. So to my functions here under the keyboard, and I go inverse cosine. And it was, I believe, 98 divided by 140. I get 45.572. 45.572. All right. So 45.572 ... All right, the question says round to the nearest whole number. So that's going to be approximately 46 degrees. All right, so that gives me two answers. I'm going to jot that down, 46 degrees. Then my last one I'm going to come to is the z. So to find z, I could do another trig function, but now that I know two angles in my triangle, I know all the angles have to add up to 190. So I can take the two that I know, 90 and 46, and I can add them together. And I get 136. I take that and subtract it from the total for the triangle, and that gives me 44 degrees for our last angle. And that's it. Have a great day, everyone. Hope that helped, and we'll see you tomorrow.